Okay, so today we are going to be talking about surface area of pyramids, cones, and spheres. Okay, so I asked you to draw a net for each of these. Okay, so I said you can pick any pyramid you want. Okay, so here's an example of a net for a square pyramid or a rectangular pyramid. Okay, I have the base, the bottom of the pyramid, and then the sides that would come up to a point. Notice, this time I have my one base and all the sides are triangles. Whereas with a prism, you had two bases and all the sides were rectangles. Okay, and then a cone looks like this. Okay, if you remember, some of you that made the figure of the cone, you recognize this shape because it's what it looked like. You have the base, the circle that's at the bottom, and then this piece curves around the circle, and this ends up being the point on the top. Okay, now if you notice, again I have my one base, which for a cone makes it a circle, but then this other piece is kind of almost like a triangle, except it just has like part of a circle on it instead of a flat side over here. Okay, so it's still very similar to the pyramid where you have one base and the sides are triangles. You have one base and the side is kind of like a triangle, more like a triangle than a rectangle anyway. Okay, and then for a sphere. Now, a sphere doesn't really lend itself to a net as well as the others, but we can actually still see what it looks like. I want you to think about a tennis ball. Okay, and if you were to peel a tennis ball apart by the seams, what would it look like? Okay, well, it has two pieces. It kind of has a curve going this way, and then it has another curve going this way. Okay, and these two curve around the sides, and this one curves around the top and the bottom. So this is what it would look like. This is what a tennis ball would look like if you ripped it open. Okay, this is what a baseball looks like if the seams are busted. Okay, so this is basically the net for a sphere. Alright, now we're going to analyze these nets to see how we can find the surface area of each of these three types of figures. Alright, so first we're going to start by looking at the formula for surface area that we've had so far. Okay, except for now, we're not going to be talking about prisms. This formula is for prisms and cylinders, right? Because a prism has two bases and the sides are rectangles. So that's why I did the area of the base times 2, and I calculated the other area like a rectangle, just length times width. Okay, perimeter times height. So 2 dimensions multiplied together. So I can see 2 bases and all the other sides are rectangles. Okay, well, that's not what I have when I have a pyramid. Okay. Okay, first we need to talk about the different dimensions. Okay, a pyramid doesn't have 2 bases. It only has 1. Right? Now, there's something else that's different too. We talked about slant height a little bit before when we were talking about volume. We talked about how we didn't need it because it had nothing to do with how much water it would hold. Well, now we're talking about surface area. And the height of a prism and the height of a cylinder is on the surface. So that's fine. But where's the height of a pyramid? It's through the middle of the pyramid. Does that have anything to do with the surface? No. But now the slant height is on the side. It's how tall this side piece is. Well, that seems like that would have more to do with the surface than the height. So we're going to see if we can alter this formula to make it fit a pyramid. Well, first thing you notice is it only has one base. So do I need to have two bases in my formula? No. I don't need two bases because there's only one of them. So I'm just going to have base. Okay, now let's look at the net for a second. Alright. So this is my base. This is my slant height. Okay, now, why didn't I put the height on here? Well, because the height wouldn't be on the net. The height would be like sticking straight out of the base, coming at you, basically. Okay, so it's not on the net. That's the reason it has nothing to do with the surface area, because it's not on the surface. Okay, now the slant height is not only on one of the sides, it's on all of the sides. So to find the area of the sides, do you think I'm still going to do perimeter of the base times height of the prism? Well, no, I'm not, because the height of the prism isn't on the surface. What is on the surface? The slant height. See, that's how tall all these triangles are, right? That's the height of those triangles. So if I'm trying to find the area of all these triangles, shouldn't I use slant height? All right, so I don't need height for a pyramid. I'm going to use slant height. All right, but one more thing. What shape are the sides here? Like I just said a second ago, they're triangles. So do we find triangles by doing length times width or perimeter times slant height? No. There's one more thing you have to do. You have to take half of it because it's a triangle. Okay, now the same idea works. The perimeter is still fine because the perimeter would be this base times the height, this base times the height, this base times the height, and so forth. But you still have to take half of it because they're all triangles. Okay, so that gives us a formula for pyramids is just area of the base plus 1/2 of the perimeter of the base times the slant height. Okay, now again, you can compare it to the original formula and it should make sense. A prism has two bases. A pyramid only has one. Okay. A prism has rectangles for sides. A pyramid has triangles. That's why we need the half. A prism has its height on the outside, on the surface. A pyramid does not. That's why we need to use slant height. Okay, so this should make sense. It's basically the same formula. It's just altered to fit a pyramid instead of a prism. Okay, so now let's look at an example. Alright, so I have this pyramid and I have my formula. Okay, the first thing I need to do again is identify my base. Okay, well that's even easier with a pyramid because there's only one choice. Okay, the bottom of my pyramid is my base. So I still have three things I need to find. I need to find the area of the base, I need to find the perimeter of the base, and I need to find the slant height of the pyramid. Okay, so the area of the base, since it's a 6 by 6 square, is 6 times 6. So that gives me 36. The perimeter of the base is 6, 6, 6, 6. So I get that the perimeter is 6 plus 6 plus 6 plus 6. So that gives me the perimeter is 24. And then the slant height is the 8. Okay, because the 8 is the height going up the side of the pyramid. I don't need the 5 meters. The 5 meters is the height. The height is in the middle of the pyramid, not on the outside. So it has nothing to do with the surface. So I don't use it at all. So I have the 3 things I need. I have the area of the base, I have the perimeter of the base, and I have the slant height of the pyramid. Okay, so I can plug it in. So I get the surface area equals 36 plus 1/2 of 24 times 8. So 36 equals 12 times 8. That gives me 36 plus 96. So my surface area is 132 meters squared. Okay, now notice, just like surface area before, I know this is actually meters squared, this one's actually meters, the 8 is actually meters. Okay, but I know since I'm finding area, it's going to be units squared. So as long as I know all of these have the same units, I can just leave my units off while I'm doing my calculations and put them on at the end. Alright, so that's how we find the surface area of a pyramid. Okay, so now the surface area of a cone. We're going to do the same thing. I'm going to start with the formula we know, and we're going to analyze it to see how we can change it to make it fit a cone. Okay, now before we do anything else, let's make sure we know all of our pieces of the cone. Okay, our base is the circle on the bottom. The height goes straight up through the middle of the cone, and the slant height is how tall it is on the side, going up the side of the cone. Okay, so very similar to pyramids. Do you think we're going to use the height of the cone for surface area? No. And why not? Because it's not on the surface. It's through the middle. So it has nothing to do with surface area. Alright, so let's look at the net. Okay, so here's what we've got. We've got our slant height and our base. Okay, and again, why did I not draw the height for the net? Because it would be sitting in the middle of this, pointing out of the board. Okay, it wouldn't be on this net. Okay, now I do want you to realize that this dotted line doesn't necessarily have to be here, because the slant height is the same everywhere. The length of this line is the slant height. If I drew the dotted line over here, that would be the slant height. Okay, so this is like a piece of a circle, where the radius of the circle would be the slant height, if you want to think of it that way. So all of these lines, if I drew any of these lines, would all equal the same thing, which is whatever the slant height is. Okay, so again, the first difference you should notice is the fact that we don't have 2 bases for a cone. We only have 1. So the first thing we need to do is get rid of that 2 again, because we only have 1 base. Okay, now that takes care of the base. Now let's look at this piece over here. Alright, first off, we know that there is no perimeter for a circle, so I'm going to go ahead and cross that out and put a C for circumference. Okay? And I know I'm not using height, since it's not even on the surface. I'm going to use the slant height for height. So I'll replace that H with an L. Alright, now we have to think about this. Okay, like I said earlier, this is kind of like a triangle. And if I wanted to find the area of this, I can find it just like a triangle. Okay? So I would have to find the base times the height divided by 2, or 1/2 of base times height to find this triangle. Well, how long is this line right here? Well, that's the circumference of the base, right? Because that's what would wrap around this circle. So that's why I have circumference up here. The circumference is the base of that quote-unquote triangle. Then the slant height is how tall the triangle is. So that's why I have circumference times slant height. But since it's a triangle, what else do I have to have? I have to have 1/2, or divided by 2. Okay? Now, before I go ahead and write down this, I'm going to simplify it a little bit more. But before I do, you can see it's basically the same equation we had for pyramids. I have area of the base plus 1/2 perimeter times slant height. Except for instead of perimeter, I have circumference because it's a circle. But it's the same exact formula. Okay? Now, this one we can simplify a little bit, though. Okay? I want you to think about what circumference is. That's pi times diameter, right? Well, another way to write that is 2 times pi times radius, because 2 times radius is diameter. So this is another way to write it. So if I was to take half of the circumference, like it says so up here, then half of the circumference would just be pi times radius, because half of 2 is 1. So I would just get pi times radius. So this half c is really just pi r. Okay, so when I write my formula, I have the area of the base plus pi times r times L. And since we're already changing it and having to memorize a little bit anyway, since the base is always a circle for a cone, we could go ahead and eliminate that b and go ahead and just put pi r squared. Okay, this is my formula for surface area of a cone. Now, if you want to still remember it like this, area of the base plus 1/2 of perimeter times slant height, because it's exactly the same as a pyramid, that's fine. Okay, but if you notice, this one's not too bad to use, because it's just pi times r plus pi times r times L. Well, the good thing about this formula too is there's no capital letters here. There's nothing to calculate. You just plug in the numbers you have from the problem, from the figure. Okay, so now we have the formula for surface area of a cone. So now let's see an example. Okay, so I've got my formula. Surface area equals the area of the base plus 1/2 circumference times slant height, or I can go ahead and use pi r squared plus pi r L. Okay, again, the first thing I need to know is where's my base. So that's the circle. Alright, so the area of the base is going to be pi times 3 squared, because 3 is my radius. Okay, so that's 28.27. Okay, now, whether I just plugged in the radius into the equation here, or whether I found the area, notice it's the same thing. So either way, I get 28.27 in this first spot. Okay, then to do the second part, pi times r times L. Okay, well, first I need to know what r and L are. Okay. Well, the radius, I've already used it, so I'm pretty confident that 3 meters is the radius. Okay, but what about the slant height? Well, the slant height has to be going up the side of the cone. Okay, not through the middle. Okay, now how do I know that this dotted line is in the middle, not on the side? Because it's kind of hard to tell sometimes when you're looking at a 3-dimensional object on a 2-dimensional surface. But look at where the dot is that it's going to. It's in the middle of the circle, so that means that dotted line is going to the middle of the circle. So that's not on the surface. Okay? So the 7 meters is my slant height. Okay, so that gives me 28.27 plus pi times 3 times 7. So 28.27 plus 65.97. So I can add those two values together, and I get 94.24 meters squared. And that's the surface area of my cone. All I did was pi r squared plus pi rl and got my surface area. Okay, now, first thing I'll say is this one's not as straightforward. Okay, I can't really do this experimentally as well as I can do the other ones on here. Okay, but I'll give you a good idea of where the formula comes from. Okay, because we can't really take these pieces and lay them across and figure out exactly what they are. But remember what the net looked like. Okay, like a tennis ball unfolded, so it kind of looked like this. Well, if you notice, I really have 4 circles through here. Okay, that's what these shapes are made of, you know, and if I had drawn it a little better, it probably would have turned out a little nicer, not had as many gaps or, you know, overhangs. But it's basically, you can see this one worked out pretty good. Each of these is made up of 2 circles, and those 2 circles are bent around. These 2 are bent around the side, and these 2 are bent around the top and the bottom. Okay, so a sphere, the net of a sphere, is actually just made up of 4 circles. You know, now they're not straight circles, they kind of get smushed a little bit into each other, but that's what they're made of. Okay, so the formula for surface area of a sphere is very simple, because if we know the area of one circle, then all we have to do is know the area of 4 circles that same size. So the surface area of a sphere is just the area of a circle, which is pi r squared, except since there's 4 circles, it's 4 times pi r squared. Okay, so this is the formula for the surface area of a circle. I mean, surface area of a sphere. So this one's actually probably the easiest one for surface area as well. Okay, so you just do 4 times pi times radius squared. That gives you surface area. Alright, so let's look at an example of a sphere. Okay, we're going to find the surface area of this sphere. Okay, so like we just figured out, the formula is 4 pi r squared. So really all I need to know is the radius. Well, it gives me the radius right here, 4 meters. So I can plug that in. I get 4 times pi times 4 squared, which is 4 times pi times 16. So that gives me 201.1 meters squared. And that's the surface area of a sphere. Now, I'm going to go back and talk about the other area, lateral area. Okay, just like the other figures, we also have lateral area for pyramids, cones, and spheres as well. Okay, so if you remember what lateral area is, it's just the area of the sides. So it's the surface area without the base. Well, here's the surface area. Isn't this piece the base? So the lateral area is just the 1/2 perimeter times slant height piece. So that's pretty simple. Again, if you did the work correctly, then you've probably already got this answer written down on your paper. You just need to be able to identify it. Okay, so this whole thing is surface area, and just the second piece is the lateral area. So looking at this example we did, if the lateral area is just the 1/2 perimeter times slant height, then it's just this number. So the lateral area is 96 meters squared. So I actually had the surface area and the lateral area for this pyramid. Same idea for a cone. Since the first piece is the base, you would leave that part off for lateral area, and you would just get that the lateral area of a cone is pi times radius times slant height. So let's look at the example, and you see that it would just be this second piece. So the lateral area would just be 65.97 meters squared. Alright, now the sphere might be a little tricky. Okay, because there's only one piece to its formula. So how do we take off the bases? Well, if you remember something about spheres, they don't have any bases. So the lateral area is the same exact as the surface area because there are no bases. So if you take away the bases from the surface area, you didn't take away anything. So this is the one figure where surface area and lateral area will be exactly the same. So if you look at this example, this whole component is also lateral area. So the lateral area is again 201.1 meters squared. Okay, so now that we've practiced finding surface area and lateral area for each of these figures, we're going to see if you can do something. Okay, so we're going to start with pyramids. You're going to find the surface area and the lateral area of both of these pyramids. Alright, so you've got a rectangular pyramid over here. You can see this is 2 meters, 4 meters, 4 meters, and this dotted line over here is what's 5 meters. Okay, notice here that this right angle is talking about that the triangle on the bottom is a right triangle. So this 3 and 4 meters are perpendicular to each other. And then this means that this dotted line is perpendicular to this solid line on the bottom. Okay, so you've got a triangular pyramid, you've got a rectangular pyramid. You need to see if you can find the surface area and lateral area of each, and then we'll look at them together. Alright, so we'll start with the rectangular pyramid. Okay, so my base is on the bottom. My formula is just area of the base plus 1/2 perimeter times slant height. So first I'm going to find the area of my base. It's just 2 by 4. So the area of the base is 8. Now I need to find my perimeter. Okay, the perimeter goes all the way around 2, 4, 2, 4. Okay, so that's going to be 2 plus 4 plus 2 plus 4. So that gives me a perimeter of 12. Now I need the slant height. The slant height will be this 5 because it goes up the side of the pyramid. Okay, well, what about the 4? I don't need the 4 because the 4 is the height of the pyramid. It's through the middle, not on the surface, so I don't use it at all. Okay, so now when I'm doing my calculations, I've got 8 plus half of 12 is 6, so 6 times 5, so that gives me 8 plus 30, so the surface area is 38 meters squared. Okay, so now that I've got surface area, I also need to find lateral area. Well, that's pretty easy. Since lateral area is just the second part of that formula, I already found the lateral area. The lateral area is 30 meters squared. So I have the surface area and lateral area for this pyramid. Alright, now for the next pyramid. I have the same formula. Area of the base plus 1/2 perimeter times slant height. Okay, the triangle on bottom is my base. So I need to find the area of that base. It's a right triangle, so the 3 and the 4 are the base and the height for the triangle. So I'm just doing 3 times 4 divided by 2. So that gives me an area of 6. Then I need to find my perimeter all the way around the base. 3 plus 4 plus 5. Okay, and that gives me a perimeter of 12. The 8 is the slant height because notice it goes all the way to the side. Okay, they don't give you the regular height on this because otherwise the dotted line would stop in the middle of the triangle. Okay, this one comes to the side, so it's the slant height. So my slant height is 8. So that gives me 6 plus 6 times 8 because half of 12 is 6. So I have 6 plus 48. So the surface area is 54 meters square. And again, since I've showed my work, I already have my lateral area as well because it's just the second part. So the lateral area is 48 meters square. Okay, so no matter what type of triangle it is, what type of pyramid it is, this formula works for it. You find the area of the base, then you do the perimeter of the base times the slant height divided by 2. Alright, last one. Let's see if you can find the surface area and lateral area of this cone and this sphere. Okay, so you've got your dimensions 3 feet, 6 feet, 8 feet, and then this all the way across this sphere is 20 yards. So you're trying to find surface area and lateral area, and then we'll look at it together. Alright, so for the cone, I know my formula is pi r squared plus pi r L. Okay, so all I really need to know is the radius and the slant height. Okay, so I've got this 3 feet. Well, that's my radius because it's half the distance across my circle, across my base. Okay, well, I've got the 8 feet. That's my slant height because it's going up the side of the cone. Well, what about the 6 feet? I don't need the 6 feet. It's irrelevant. It's not on the surface. Okay, so all I need is the 3 and the 8. So I'm going to plug it in. So I get pi times 3 squared plus pi times 3 times 8. So that gives me pi times 9 plus pi times 24. So I get 28.27 plus 75.4. So that gives me a surface area of 103.67 feet squared. Notice I have to make sure I match units, and I always know it's units squared because it's area. And as easily as the other pyramids, the lateral area is the second part of my formula, so I already have that answer as well. So the lateral area is 75.4 feet squared. Okay, now for the sphere. I have a nice easy formula for this one. Surface area equals 4 pi r squared. So all I have to know is the radius, and that's it. Well, too bad they don't give me the radius, because this 20 yards goes all the way across the sphere. So this 20 yards is the diameter, which means the radius has to be 10. The radius is 10 yards since the diameter is 20. If it's 20 all the way across the sphere, then it's 10 halfway across. So that gives me 4 times pi times 10 squared. So 4 times pi times 100. And I can multiply in any order I want. So 4 times 100 is 400. So 400 times pi is 1,256.6 yards squared. Okay, so that's the surface area of this sphere. Well, what about lateral area? Well, since I know that lateral area is exactly the same as surface area for a sphere, then it's exactly the same answer. Okay, 1,256.6 yards squared. So at this point, we should be able to find surface area and lateral area for any pyramid, cone, or sphere.